We've done the first 4 quests of this, so let's move on to quest 5. Let's see how much fun this is going to be. Let's find out. Quest 5, pseudo-random clap dance. Okay. No grand tournament is complete without lively music and spirited dancing. As evening falls, crowds gather in the main square to partake in the whimsical pseudo-random clap dance. All right. So everybody chooses one of 4 columns. Okay. And we have rounds. I'm just going for the highlighted stuff here. Each round featuring one person designated as the clapper. Clapper moves to the beginning of the column to their right, facing its members. Clapper is from the 4th column. They move to the start of the 1st column. Okay. I see columns here. All members of that column extend their arms to the sides. Clapper dances around the column from the left, high-fiving each extended hand. Upon reaching the end of the column, they switch to the right side and continue in the opposite direction. The crowd counts each clap out loud, starting from 1. When the shouted number matches the clapper's chest number, the absorption occurs. Clapper can be absorbed into a column in 2 ways. If they're encircling from the left side, they're absorbed in front of the person. They're on the right side. Oh, okay. So you go down. All right, well, here's an example. Practice predicting the flow of the dance. All right, so first column comes off and then works its way down here until it hits 2, because it's a number 2. I get it. And then we go in front of, okay. And then the people in front combine their numbers and shout. Where was that? Oh, after absorption, the first person from each column combines their numbers into a single large number, shouting it out loud before the next round begins. Okay. So then the 3 comes off here, goes down 3, and it gets absorbed. And then they shout the starting numbers. Okay. What number is it shouted at the end of the 10th round? All right. Let's grab our input. Cargo new. Day 05. And then we're just stealing the AOC lib workspace business here, so that I have access to all of my helper codes. Let's go to day 05 here and run bacon. Bacon test, I guess, would be a good start. And what we can do is make their input, move downloads everybody codes to input. Let's see what it looks like. Okay, so this is my input, and it looks very similar to the test input. All right. So it seems like we wouldn't really need to edit the test input. Let's save this. Let's pull up main and do this. Let numbers is a vec of I64 equals AOC lib numbers input oops, let's do it this way, ls input. There we go. So this will give us all the numbers as a vec of vecs, but then we have to transpose it. Because this is going to give us horizontal. Okay. So this is, let's call this data, and then we'll create a new vector called numbers. Vec new. And then we can loop over each of the rows of data and stick it into different numbers. Oh, we know it's going to be a vec of 4. Oops. All right, so this is going to be a vec of unknown. Oh, we don't know it yet. Okay, yep. So we say for line in data, we'll say numbers, for idx num in line iter enumerate numbers of idx dot push num. And this should give us it transposed. Oh, I have to provide the separator character. Line is a vec of 64. Oh, then what's num? Oh, okay. Let's do that. There we go. And we can actually write it. Yeah, I have tests going on here, so we can do something similar here. Let's extract this code. Let numbers equals transpose data. Fn transpose data vec of I64, I think, and that returns a vec of I64, and then just numbers. Oops, I forgot that. Okay, so this should work. If I print out numbers now, and the reason I extracted it was so that I could write a test, right? Numbers. If I run, are we getting 35453, 25322? Yep, and then 43442. Okay, good. We're going to switch back to test here because I want to write a dance function. So we have transpose. Let's write a test. Yep. Test mod like that, and then test transpose, I guess. And we'll start off with this guy here, which I probably already copied. Let's write a little function lines, which returns a vec of I64, which is going to be the untransposed data. So it's vec bang of this. And then this is going to be comma, and then we'll finish it up here with a comma. I forgot the comma, and then this goes like this, right? And then we can get, why doesn't that work? Oh, okay. Can I do it that way? I don't know if this is going to work. Oh, I have to put vec bang on each one of these. Okay, let's do that. There we go. Okay, so now we're going to test the transpose to make sure that the transpose works. Let lines equals, yeah, let's just call it data, because that's what I've been calling it up there. Equals data, like that. And then we're going to say let numbers equals transpose data. And then we're going to say assert EQ vec bang 2, 3, 4, 5 is going to be numbers of 0. We'll just assert 2 of them. The last one here is 5, 2, 3, 4. That should be sufficient, right? And that works. Okay. So the next thing we have to write is a function called dance, which will take a dancer and a vector that we're going to stick it into, right? So 3, 4, 5, 2, for example. We'll call it line, maybe, vec I64, and it'll mutate it. And right now it's going to do nothing. Okay, so now we can write a test, and we're going to test different kinds of dancers, right? So let's figure out what the dancer needs to do. we have, here's an example of 4 entries. So we have a 3, 4, 5, and 2. And we're putting a 2 in there. But let's do it for all numbers 0 to 9. There is no 0, right? Because you have to go before. So 1 would go here, right? Because it goes before the number, or before the thing. 2 would go here, 3 would go here, and 4 would go here. And then if we're coming the other way, 5 would go here, 6, 7, 8. Let's just be consistent here. And then 9. 9, 8, 7, oops, 7, 6, 5. And this is the line that they're dancing into. Okay, so how would we do this? It looks like it's mod by double the length, and we can figure out where to put it based on that. If we subtract 1 from the dancer, let's first write a test to see if we can dance into it from going down, right? Because this is 9, and then 10 would start over here, right? 10, 11, 12, 13, 14, 15, 16, and then 17. Yeah. So it's mod by the length. Okay, well let's write a test first. Test forward insert. First we'll get the data and get the numbers. And then we're going to say dance. We're going to dance 2 into numbers of 1. And that's this example here, 3, 4, 5, 2. And then at the end of it, we should have vec bang of 3, 2, 4, 5, 2. And the actual is going to be numbers of 2. Oh, can't mutate immutable. Okay, we'll fix that. Okay, and we didn't do anything yet. But I think what we need to do is, for this, it's let position is equal to dancer minus 1, line dot insert position. This has to be a U size. Dancer. Ooh. Where did it put it then? Oh, because I put number. That was dumb. Number is 1. There we go. Okay. So we can do a forward insert. Now we should be able to do a backwards insert, right? Let's test that. Test, reverse, insert. And it's basically this whole thing here, except we're going to insert it as a higher number, higher than 4. So let's do a 6. And a 6, so it should be 3, 4, 5, 6, 2. That's what it should end up being. 3, 4, 5, 6, 2, like that. And that failed. Right, because we're not wrapping it. Okay, so now we have to say mod. Actually, we have to say if pos is less than line len. We can do this. Else, if pos minus, then we get pos minus line len. Right, because if it's 6, we want to subtract 4. Oh, no, we want the other way around. Right, so 5 needs to become the end. Right, so this is not 5 anymore because you subtracted 1. So this is 0, 1, 2, 3. 4 gets the end, so that should be an easy one. 5 should be 0, 1, 2, 3. 5 should be 3. 6 should be 2, and 7 should be 1. And then 8 should be 0 again. So it's line len. I can't subtract pos because it's bigger than line len. But it's subtracting pos minus line len, which we should be able to simplify. Oops. And I didn't finish my code before I saved it. We should be able to simplify this, but this should give us the new insertion point. If pos, just line insert pos dancer. And that works. Let's make sure we can do this last one here. Let's do insert of, because I think I have I don't know if the insert will work. Let's do dance 5. And this should be 3, 4, 5, 2, 5. Oh, I can't call it that. Test end insert. Okay, that works fine. Okay, good. So now we're able to do that, but I want to now test looping around. So if we had a dancer number 9, 10, 11, 11 would have to go in here. Although we don't need to worry about that for the first input. Maybe that'll come with the second input. Right, because the first input was just single digits. It'll never loop around because each column is 5 long. Okay. Should we just do problem 1 then and get that done? And then, oh, right. We have to figure out what the number is. What number is shouted? Okay, so we have the dance routine. We have the transpose routine. Let's write a part 1 function. Part 1. Numbers is back of I64. And we're going to return what number is shouted. I'm going to return a string because I don't want to have to convert it into a number. It'll just be easy to format. So let's take the dance column. Let mut call equals 0. We'll start with that. And we're going to go 10 rounds. So for underscore in 0.10, we're going to pull an entry, dancer, from the column that we're dealing with, numbers dot remove 0. Oh, numbers of call, remove 0. So this will give us a dancer, and then we're going to dance into the next column. So we're going to say call equals call plus 1 mod numbers len. I'm doing it this way. I know it's supposed to be 4, but and then we're going to dance into that column. Dancer, numbers, call. Oh, I forgot to make it mutable. This needs to be mutable. And then we need to say return the first. So we say numbers iter. And these are going to be the value, the columns. So we'll say call of 0. Actually, we can say format bang. This might be silly, but this should work. Call of 0. Collect. And then we just call println part 1 equals part 1 of numbers. Oops, that. Doesn't like, this needs to be mutable then. And let's run it. We got 5352. Sounds reasonable. It's going to be 4 digits and it's going to be all in range. Nothing can crack me down. Look at that. Took me 21 minutes to get it. And we're 623rd on the global scoreboard for that. Okay. Very good. Git status. Git add this. Git commit -am 2024 KOA 2024 Quest 5 Part 1. There we go. All right, so part 2. The first dance went exactly as you predicted, so you feel ready for a real challenge. For the upcoming dance, the Master of Ceremonies meticulously assigns numbers and personally positions participants in columns. The king takes the stage once more. As you know, I love speeches that start with "as you know." In our traditional dance, some of the numbers shouted at the end of each round can eventually repeat. The next dance will conclude in the round where one of the numbers at the end of the round is shouted for the 2024th time. Your task, my dear knights, is to predict this number and the duration of the dance. Multiply the final number by the round in which it was shouted for the 2024th time. Get your final answer. Good luck. Okay. So let's grab that. We'll test part 2. Test part 2. And I'll write a part 2 function here. This I should rename to part 1 data because it looks like we're only used it for part 1. So data is equal to vecbang of this. Like that. Okay. And then we're going to transpose it. And then we're going to run part 2, and it looks like we were going to shout. Oh, I see. We're going to get this number. So assert EQ, this number is equal to part 2 of numbers. And part 2 doesn't exist, so let's write it. So we just need to do the dance and then keep track of what number is shouted. So this is, I was thinking when I wrote this, well, we'll only do it once at the end of the dance. But now we have to do it once at the end of every round. So it might be slow. I'm going to store it in a hash map, which keeps track of how many shouts each number has shouted. Let mut shouts equals hash map new. So we're going to keep dancing, loop forever. Let's start with column 0. Loop forever until we break. I'm going to get the dance. So I should probably write a step forward function, call plus equals +1 mod numbers len. Oh, I never got the data. Let's get the data. See what it looks like. Nope, P2. Okay, so this is bigger now. I'm glad I wrote that dance function. Although I probably will need to mod it at this point. The position should be this mod the length of the column. Because it looks like we're going over. Mod line len. Yeah. And hopefully the tests still pass after I do that. Tests. Oh, part 2 doesn't exist yet. Well, unfinished. string. Oh yeah, we have to pull in hash map. Okay, and we're not even going to do that. Oh. Right. This toString. Okay. I did break it. So I'm glad I tested this. So let's take out that mod and see if it still works. Yeah, so part 2 doesn't work. Let's just take out that completely because all of the all of the unused code, unreachable expression, break. How about that? Boy, all this stuff just to clean up this. Okay, and then part 2 we'll worry about later. And then dancer. Okay. All right. So our tests work. And if I mod it by the length, for some reason it doesn't work. All right. This should be mod line length. Oh, mod by twice the line length. Yeah, okay. And then let's simplify this expression here. This becomes minus pos plus line length here. So we have, again, twice the line length minus the pos is the answer to this one. Okay. Let's call it size equals 2 times line len. And then we can just say mod size. And this is size minus pos. All right, so these tests pass. Let's go back to part 2. Let's do this. Let's add the hash map back in. We get rid of these things here, and then we're going to do the dancer like that. I'm going to keep looping until we've shouted the 2024th shout. Okay. So we're going to get the shout, which is this. I probably have to tell it it's a string. Oh, dancer. Okay, there we go. And then we're not using shouts yet, so we can now say let entry equals shouts dot entry of shout. I guess we'll put the type there. It's going to be a string to a usize. And that way this should be a pointer to the usize. All right, so we have the entry. Let's say or default, which would give us a 0. And then we can just say entry plus equals 1. If entry equals 2024, break. Really? I do it that way? I have to deref it and deref it. Now it's saying remove the mute. Oh, I see. I was trying to change the thing. Okay. All right. So now test pass. And we're getting one warning that part 2 is never used. Let's use it. Oh, oops. I forgot to actually shout this thing that I need to shout. Okay, so let's return the shout instead of this. Say return shout. Oh, I have to clone it into there each time. That's annoying. Oh, right. I forgot. You need to multiply. What was it? You need to multiply the two numbers together. It's the end of round 8095. Okay. For round in 0 dot dot. So now I have to undo the shout. I have to multiply the shout by the round. Let shout equals shout parse usize. Unwrap, and we're going to turn shout plus times round. Oh, this probably should start with round 1, right? Oh, and then it has to be converted into into a string again. Oh, yes. Ran out of numbers in usize. There we go. Test part 2 works. Okay, so let's run it for real. Change this to part 2. Change this to part 2. And see if it works. Oh, I never saved it. That's a big number. That seems too big. Let's find out. Oh, I cranked it like a pro. All right, we got 561. Nice. Okay, let's check. Let's commit part 2. Oh, you know what I haven't been doing is checking with Clippy. Yeah, Clippy. Oh, Clippy has some suggestions here. Let's clean that up. Use a format to build a string from an iterator. And instead what we should do is call fold. Oh, interesting. And use the right macro here. Okay, interesting. So we fold with a string new. Output comma column. Oh, and then we don't use this. Why is it saying unknown? And then we're going to say right. How does that work? Normally it puts a little suggestion in here and say, do it this way. But I don't see it doing that. Let's see if we can say right output. Let's see if what gets accepted here. Oh, numbers. Closure takes 2 to, oh, I see. That's why I put it in a tuple. There we go. Yeah. And then this, it said to use right. Oh, I need to import the right trait. It still doesn't like it. Expected string sound result. Look, I'm just doing what you suggested, man. Maybe we can say append instead. Output append. Push. What does push do? Push takes a character. Push dir takes a string, right? Yeah, so I can say format bang call 0. Oh, okay. And then I'd have to say output again. Oops. Cannot borrow as immutable. So this is more efficient. This is what you're telling me. And then I'm doing the same thing here. So we could just do this here, right? Okay, does it still work? It's very slow, but I think that's the same answer. Ends in 59030, yeah, okay. We might have to do it in release mode. All right, now that Clippy's happy with this, let's commit these changes. Git commit -am. Yeah, we can just do this. Part 2. And let's take a look at part 3. Time for the final dance. The master of ceremonies once again arranges everyone with the utmost care. The king presents another riddle. Sadly, every good time must come to an end eventually. Well, what if our next dance were to go on forever? Can you predict what would be the highest number that could be shouted? Okay, this is when we quit out of this because we might end up writing an infinite loop. Assuming this dance would never end, the highest number shouted would be 6584. How do we know when we're done? It's basically part 2, but keep track, instead of keeping track of how many times something's been called, we convert it into a shout and then take the max. All right, let's get the input. Oh, this one's smaller. That's unusual. Usually they get bigger. Part 3. I wonder if the biggest number that it could shout is just the, take the biggest number from this one and this one and this one and this one. I mean, we could try it and see what happens. Let's do this really quickly here. Grab part 3. Okay. Oh, and again, it was 4 columns, wasn't it? Yeah, so it's always been 4 columns. I've never had to mess around with that. There is no part 3. Let's write a part 3, which is basically part 2, but instead of keeping track of the shouts, all we need to do is keep track of the max. Let's call it max shout. Okay, so we do that, and then we'll do that. And I guess we don't need to know the round that we're in anymore. So this can be a loop again. And then let's just print out some maxes, right? So we can say if shout is greater than max, shout println max so far is equal to shout, max shout equals shout. And let's just let it run for a little bit. It's not complaining that it never returns, but I guess we can live with that. Cargo run release. That was fast. So we got this. Who knows if it's the biggest? Let's just give it a shot. Oh, I quacked it out of the park. So how do we know? How do we know if that's the biggest number? Because this is not using the suggestion that I was doing, right? If we look at the input, we can see there's numbers bigger than 1006 here. Maybe there's a repeating pattern. And once the pattern repeats, we know we'll never get a bigger number. Let's put this back for round in 1 dot dot. And we can just say how many rounds it is. So I can cut it off after rounds. Okay. 132 rounds. So that's not a lot. Let's find out if we do repeat. What we can do is create a hash set. Loop detector, hash set new. And what we can do is after we do the dance, we can say if loop detector insert numbers clone, then we're going to keep going. Else we found the answer. So we're going to return format bang max shout. We have to pull in this. No method name clone on numbers. Oh, okay. We have to make it a vector so we can clone it. All right, let's see if we detect the loop. Yes, look at that. So that's the answer to that problem. So we don't have to print out this max so far anymore. So we can just say max shout equals shout max shout. And we don't care about the round anymore, so we can slip that back to a loop. And that never gets to there. Cargo run release. Okay. I didn't break any of my tests, did I? And cargo clippy. Ooh, doesn't like that. Yeah, I need that so that I can. Oh, to owned. Interesting. I knew about to owned, but I thought that was only ever used for strings. You're lost. I'm actually about to start Advent of Code. I'm using a different programming challenge as a warm-up. How have you been? How are the little ones? I miss your streams. Okay, cargo run. Yeah, so we got the same answer.